Today's lesson is on MB and the graph of y equals mx plus b. By the end of class today, you should be able to use slope to identify parallel lines. Looking at these three examples, we are going to identify the slope, intercept, and whether the function is increasing or decreasing. With this first example and Shauna, it says 10 times t plus 0. Okay, if we think about this as money in a savings account, the slope would be 10. She's adding $10 a week to her savings account. The intercept would be 0. She had no money in the bank account when she started. And since the sign shows that she's adding money, this is an increasing function. Manuel is losing or spending $50 a week. His intercept is $1,050. That's how much money he started with. And he is taking the money out, so the slope is decreasing. In the third example, Manuel is spending $100 a week. He started out with $1,050. And since he's spending money, it is a decreasing function. In number 1 for the core activity, the line shown here has a slope of 1. We're asked to draw some other lines with different slopes, the first one being a slope of 3. So if we start at the origin and count up 3 and over 1, you see the little blue dots. Connecting these dots, this line has a slope of 3x. The next slope is 0.5. 0.5 as a fraction would be 1/2. So from the origin, counting up 1 and over 2. A line with a slope of 1/2 would look similar to this. A line with a slope of -1 would start at the origin, and we would go up 1 and to the left 1 point, making a line showing a negative slope. And the last line has a slope of 0. A slope of 0, when we saw Terrence, would be that he was not moving. So on a graph, slope of 0 would be right along the x-axis. All of these lines go through the origin. Pause here for number 2 and fill out letters A through G, comparing the slope of different lines, and then restart it to check your answers. You probably see that parallel lines are never going to intersect. This is because they have the same exact slope. So two other lines that have the same slope as the line shown here in blue would have a slope of 1. One is drawn above the line, one is drawn below. They have the same slope but different y-intercepts. Pause the video here so you can fill in number 7 and then check your answers, identifying the y-intercept and the slope for each of these 4 lines. Question 9 is filled in for you with 4 lines, 2 with a positive slope, 2 with a negative slope. Please pause the video and complete the table for number 10, identifying the y-intercept, slope, and then putting those 2 pieces of information together into the function rule in the form y equals mx plus b. M will be the slope, b is the y-intercept. Now that you have investigated the slopes of parallel lines, go back to question number 5 and fill in your current understanding of the definition for parallel lines, including all of the details for the slope and the intercepts that you have figured out today. For question 12, using complete sentences, describe the effects that the slope m and the y-intercept b have unparallel lines. In 1a, the first equation starts with an intercept at positive 1, and the slope is 0.75x. This is positive. 0.75 as a fraction means 3 over 4. So from 1, we would go up 3 and over 4. Up 3 over 4. Okay, or down 3 and over 4. So make a line that looks kind of like that. Okay, the second line starts at negative 2 and has the same slope of up 3 and over 4. Okay, you can see from the equations that these two lines have the same slope, so you know that yes, they are parallel, and you can tell if my lines are a little bit straighter that they would never intersect. In B, the first equation has a y-intercept of positive 3 and a slope of 0.5. 0.5 as a fraction is 1 over 2. The second equation has an intercept of negative 5 and has a slope of 1.25, which is the same as 5 over 4. These two lines would end up intersecting, so we know that they are not parallel and their slopes are not the same. For question 2, the equation of this line can be written if we look for the y-intercept, which is at negative 3, and if we find the slope from two other points, the ones here with the triangle show a vertical change of 3 and a horizontal change of 2. Add in the x and the y, so the equation is y equals 3/2 x minus 3. Question 3 has two parts, the first being to graph the function y equals 3x plus 5, starting with the y-intercept at 5, and then counting and adding other points using the slope of positive 3, or 3 over 1. Okay, the graph would look similar to this. On the same grid, graphing the effect of decreasing the y-intercept by 7 means that we would move the y-intercept down 7 to negative 2. The slope would be the same. So these lines would be parallel. For question 4, to write the equation of a line that's parallel to the one shown here, y equals negative 1/3 x. To be parallel, it has to have the same slope, so negative 1/3. Okay, but instead of a y-intercept at 4, the y-intercept would be 9 units above. So adding 9 to negative 4 would make the intercept at positive 5. For question 5, okay, using a similar equation, okay, the slope of this line would stay the same, 2x. Okay, but instead of a y-intercept at negative 4, the point here shows where x equals 0, y equals negative 1. So this is a different y-intercept. Please use this information to help you finish the homework and staying sharp. It is due at the end of period 2, unless you want homework over the vacation, which I really don't think you do. Have a happy Turkey Day.